So hi, I am getting ready to do a video on how to deal with I don't even know what we're doing. How to deal with rational expressions. Now we're talking about how to deal with rational expressions. If you don't know how to factor, rational expressions is going to be a nightmare. So you really want to make sure you're sharp in factoring in order to get through the rational expression section. So I would like to start out with how to simplify a rational expression.
So let's take a look at this fraction 6 over 15 and think about how we would reduce that. What I'm going to do is break up the 6 into 2 times 3. And then I'm going to break up the 15 into 5 times 3. This is basically like factoring a polynomial. And if you look, you have a 3 at the top and a 3 at the bottom, so those can be canceled out. And that's how we reduce the fraction into 2 over 5. A rational expression works in the same way. So let me write an example down and let's approach it the same way that we would approach a fraction. I have x squared plus 13x plus 12 over x squared plus 12x. Now, to start out this problem, let me factor the top and factor the bottom. At the top, I'm going to get x plus 12 and x plus 1. At the bottom, I can factor out an x and I'm left with x plus 12. Now, if you notice, I have two factors that look the same, and that's the x plus 12. When I cross those out, I'm left with the answer of x plus 1 at the top and an x at the bottom. And this is going to be our final answer. Let's look at another example. That's 3x squared minus 8x minus 3 all over 2x to the 5th minus 18x to the 3rd. Now, because we're going to have to use the AC method here, what I'm going to do is take the polynomial at the top and just write it in another section. So I'm able to do factor by grouping, or the AC method. So I'm going to take 3 times negative 3, and I get negative 9. I need to find two numbers that multiply to get negative 9, but when I add, I get negative 8. This is our AC method. And those two numbers are going to be negative 9 and 1. So I'm going to rewrite my polynomial using negative 9 and a 1 for my middle term. And then I do factor by grouping. Now, once I'm complete with factor by grouping, I'm left with x minus 3 and 3x plus 1. So I'm going to write this back in my rational expression for the numerator. Now, in my denominator, I can take out a GCF, and that's going to be 2x to the 3rd, and I'm left with x squared minus 9. I can continue to factor inside the parentheses, and that's going to be the difference of two squares. So I'm going to rewrite what I have in the numerator, the x minus 3 and 3x plus 1. And in the denominator, I have the 2x to the 3rd, and then I factor x plus 3 and x minus 3. So what factors look the same? I can cross out the x minus 3, and that will leave me with 3x plus 1 at the top and 2x to the 3rd, parentheses x plus 3 at the bottom. And this is my final answer.
Next, let's talk about how to multiply rational expressions and also to divide. Multiplying and dividing, they go hand in hand. So let's go ahead and talk about multiplying and dividing rational expressions.
So again, let's look at some simple fractions to see how we would multiply them. So I have 18 over 35 times 14 over 9. So I want to simplify or factor each one of the numbers first. So the number 18 can be broken up into 2 times 3 times 3. The number 35 can be broken up into 5 times 7. The number 14 can be broken up into 2 times 7. And then the number 9 can be broken up into 3 times 3. Now, the goal is to cross out anything that looks the same at the top and bottom. And when I look at these expressions, I have a 3 at the top and bottom, and I have another 3 at the top and bottom. And then I also have a 7. That leaves me with 2 times 2 over 5. And 2 times 2 is 4 over 5, and that gives us our final answer. So let's take a look at a rational expression and approach it the same way. I have p squared minus p minus 6 over 3p minus 9, 2p squared minus 5p minus 3 over p squared minus 3p. So since we have a lot of polynomials in both of these rational expressions, let's take this one step at a time. Let's look at this first polynomial, and I'm just going to bring it to the side to factor it. So I have p squared minus p minus 6. This could be factored by putting a p in each one of my parentheses. I need to multiply to get negative 6, but when I add, I get negative 1, and those two numbers are negative 3 and 2. So I put negative 3 and 2 in my parentheses, and this is completely factored. So let's look at the second one. I have 3p minus 9. And on this one, all I can do is take out a GCF, which is 3, and I'm left with p minus 3. And let's look at the third one. I have 2p squared minus 5p minus 3. This is going to require the AC method, where I multiply the first number times the last number. So if I multiply 2 times negative 3, I get negative 6. And I need to multiply to get negative 6, but add to get negative 5, and that's negative 6 and 1. So I use negative 6 and 1 to rewrite the middle term, so I can do factor by grouping. The first two terms, I can take out a 2p. The last two terms, I can take out a 1. And my parentheses look the same. So I have p minus 3 and 2p plus 1. Last but not least, I have the last polynomial, which is p squared minus 3p. And on this one, I take out a GCF of p, and I'm left with p minus 3. And that is completely factored. So I'm just going to put a box around each one of my factored polynomials, because what I'm going to do is take all of this and bring it back together in my rational expression. So I have each one of my factored polynomials in the correct position, and now I need to figure out which factors look the same at the top and bottom. So on this one, I can cross out p minus 3. I can also cross out another p minus 3. And everything that's not crossed out is my answer, so I have p plus 2 and 2p plus 1 over 3p. And this is my final answer. So dividing rational expressions, let's start out by looking at a set of fractions that I want to divide. So I have 3 over 25 divided by 9 over 5. Now, to divide fractions, you have to flip the second and turn the division into a multiplication symbol. So I'm going to do that first. I'm going to flip the second fraction and then change my division to multiplication. And then I'm going to factor each one. Or each one of my numbers. So I have 3 over 25 can be broken up into 5 times 5 times 5 over 9 can be broken up into 3 times 3. And again, I cross out anything that looks the same at the top and bottom. And that leaves me 1 at the top and 5 times 3 in the denominator. So my answer is 1 over 15. Okay, here we have 2 rational expressions that we are dividing. So just like the numbers, what I want to do is flip the second rational expression and change my division into a multiplication symbol. So I'm going to rewrite all of this, flipping the second rational expression and changing the division into multiplication. If I flip the second rational expression and change the division into multiplication, this is what I have. And now I do the exact same thing I did when I had multiplication. I'm going to factor each one of my polynomials. And I'm going to take them to the side to factor them individually. So I have number 1, x squared minus 5x plus 6. And with this one, I need to find 2 numbers that multiply to get positive 6, but add to get negative 5. And that is negative 3 and negative 2. For the second polynomial, I have x squared minus 10x plus 16. And I need to find a number that multiplies to get positive 16. But when I add, I get negative 10. And that's going to be negative 8 and negative 2. For the third polynomial, x squared minus 6x minus 16. And for this one, I need to find a number that when I multiply, I get negative 16. And I add to get negative 6. That's going to be negative 8 and positive 2. And for the last polynomial, the only thing I can do with this one is take out a GCF. And the GCF is going to be x. So I'm going to rewrite each one of my factored polynomials. And I'm going to put them in their correct position so I can start canceling factors out. So at the top I have x minus 3, x minus 2. At the bottom I have x minus 8, x minus 2. And for the second rational expression, I have x minus 8, x plus 2. And at the bottom, x plus 2. And now I'm going to cross out anything that looks the same at the top and bottom. X minus 2, x minus 2. X minus 8, x minus 8. And x plus 2, x plus 2. So my final answer is x minus 3 over x.
Now we're ready to talk about adding and subtracting rational expressions, and let's take a look at it.
Adding and subtracting rational expressions. So let's take a look at 2 fractions and see how we add these fractions together. I'm going to start out by factoring the denominator. I have a denominator of 18. So that can be broken up into 2 times 3 times 3. And for the second fraction, I have a denominator of 12. And that can be broken up into 2 times 2 times 3. So the goal here, in order to add or subtract fractions, they have to have the same denominator. And as you look at these fractions, they do not have the same denominator. So what I'm going to do is fill in the gaps on what's missing from each denominator. If you look at the first denominator, you have 2 times 3 times 3. And on the other side, I have 2 times 2 times 3. So for the first denominator, I'm missing a 2. So I'm going to multiply the top and the bottom by 2. So I multiply the top by 2 and the bottom by 2. On the second fraction, I'm missing another 3. So I'm going to multiply the bottom by 3 and the top by 3. And when I rewrite each fraction, I have 2 times 5 at the top, which makes 10. And then all the numbers at the bottom make 36. For the second fraction, I have 7 times 3, which is 21, and then the bottom again is 36. So the denominators look the same. I have 31 over 36, and this is my final answer. So what we have here is two rational expressions that we want to add together. If you look at the denominators do not look the same. So just as I did with the fractions above, I'm going to try to factor each one of my denominators to see if I can make them look the same. So for the first fraction, I have 3 at the top, and at the bottom I can take out a GCF, and you're left with 2x plus 9. And for the second rational expression, I have 27 at the top, and the bottom is the difference of two squares. So you get x plus 9 and x minus 9. So if I think the same way I did with the fractions above, I'm filling in the gaps on what's missing. So if you look at the first rational expression, I'm missing an x minus 9. So I'm going to multiply the top and the bottom by x minus 9. But on the second rational expression, I'm only missing a 2. So I multiply the top and the bottom by 2. So let's rewrite each rational expression. I have 3 times x minus 9. And in the denominator, I have 2, x plus 9, and x minus 9. For the second one, I have 27 times 2, which is 54. And then in the denominator, I have 2 times x plus 9, x minus 9. My denominators look the same now, so I am able to add across the top. So I'm going to go ahead and distribute the 3 and get 3x minus 27 plus the numerator of the second fraction, which was 54. And all of this is going to be over the same denominator, 2x plus 9, x minus 9. If I combine my like terms across the top, I got 3x plus 27 over my denominator, 2x plus 9, x minus 9. And before I call this a complete problem, I'm going to factor across the top to see if I can reduce this further. And I can, because if I take out 3, I'm left with x plus 9. And there's an x plus 9 in my denominator. So x plus 9 can be canceled out. So my final answer is 3 over 2 times x minus 9. Okay, let's try an example with subtraction. Same thing, your denominator needs to look the same. And with this rational expression, the denominators do not look the same. Both of my denominators are factored completely though. So I can go ahead and start filling in the gaps on what's missing from each side. For the left rational expression, I am missing an x minus 4. So I'm going to multiply the top and the bottom by x minus 4. For the right hand side, I'm missing x minus 1. So I multiply that on the top and bottom. So let's rewrite our rational expressions. This is x minus 4, over x minus 4 times x minus 1, minus, the other side I have x minus 6 times x minus 1, over x minus 4, x minus 1. So my denominators look the same now. I'm going to take the next step and distribute the x squared minus 4x over my denominator. And on the left hand side, I'm going to FOIL. So x minus 6 and x minus 1, in order to bring those together, I have to FOIL those two polynomials together. And across the top, I end up getting x squared minus x minus 6x plus 6. I can finally subtract across the top. So what I'm going to do is rewrite everything so it's all together in one fraction. So I have x squared minus 4x minus, notice how I put the second numerator in parentheses. And the reason why I'm doing that is to make sure that that negative sign is distributed to each term in that second polynomial. That negative sign needs to go to each term in the polynomial. So x squared minus x squared, that makes the x squareds cancel out. And then you have negative 4 minus negative 7, which is going to give you 3x. And then you have minus 6 over my denominator. If I try to factor across the top, nothing cancels out with the denominator. So this is our final answer.